Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to examiners, lecturers, and my fellow friends. I'm Haziemah binti HAZDRI from class CS245B. So my final year project proposal entitled Chest X-ray Detection Using Deep Convolutional Neural Network DCNN. My supervisor is PM Dr. MARINA YUSOFF, and my co-supervisor is Madam SHAMIMI Abdul HALIM. Here's our table of content. We will go through one by one for all these parts. Research background. Medical imaging is the practice of creating visible images of the body internal system for research and therapeutic research and care, as well as a visible representation of the function of the internal tissues. Some common types of medical imaging other than X-ray are computerized tomography, most generally referred to as CT scan, and magnetic resonance imaging, most generally referred to MRI. X-ray are one of those types in medical imaging. This technology uses low-dose radiation and a specialized plate to produce images of inside the body, especially the bones and joints. Next, CNN is one of the different versions of neural networks and is widely used in image recognition research findings. Contains convolutional layers, pooling layers, fully connected layers, and a classification layer. So the convolutional neural network apply multiple layers of convolution operation to extract translation and scale invariant features from images and are widely used to analyze radiology image content to assist in diagnosis. DCNN have achieved expert level performance for various chest pathologies. Problem statement. The sensitivity of chest X-ray compared to CT scan. In recent small studies in other communities, CT scan was found to be more sensitive to radiographic pneumonia finding than chest X-ray. Compared to chest X-ray, higher sensitivity of CT scan is possibly due to better visualization of chest cavity region that are not well imaged with chest X-ray. Next, lack of X-ray images are used in features chest X-ray detection. Most studies in chest X-ray have only been carried out in small data size. Previous study have claimed that due to the lack of knowledge on COVID-19, there were certain shortcomings in the analysis. So the study indicated that chest X-ray could be more useful in diagnosing COVID-19 with the aid of more evidence on good resolution images. Other than that, other papers also claim that the limitation of the analysis was that more images were used in a range of X-ray images for better results. This showed that lack of data can lead to low performance of the model. Research question. So this paper included some research questions as listed below. First, what is a suitable method in image processing that can give good results for chest X-ray image detection? Second, how to develop a model with deep convolutional neural network CNN architecture. Thirdly, how to identify the abnormalities in chest X-ray. Research objective. The research objective of this research are to determine the suitable method in image processing that can give good results for chest X-ray image detection, and to develop a model with deep convolutional neural network CNN architecture. Research scope. The scopes of the research are: first, deep convolutional neural network CNN as the main technique. Second, presenting a comparison of recent deep convolutional neural network architecture. Third, focus on features of the X-ray images to detect the abnormalities in the images. And lastly, 50,000 X-ray images will be used. Research significance. This project develops and integrates a deep convolutional neural network, DCNN, to identify chest X-ray images, which can be used as an auxiliary device to assist in the efficient detection of artificial X-ray images of disease. Also, the system with a deep convolutional neural network, DCNN, is used to enhance the accuracy of the diagnosis of chest pain in terms of accuracy. Next, literature review. For chest X-ray as the domain, what is chest X-ray? Chest X-ray are widely used for diagnosing abnormalities in the heart and lung area. Chest X-ray also are considered as the most effective method to determine the extent and location of the septic region in the lungs. So next, the advantages of chest X-ray are fast imaging speed, low radiation, and low cost. Clinically, chest X-ray is the most commonly used imaging modality in the diagnostic workup of patients with lung abnormalities. And types of disease that chest X-ray can detect are pulmonary tuberculosis (TB), COVID-19 or viral pneumonia, and pneumonia. For the techniques, there are a few techniques that will be used in this project. First, DCNN as the main technique, as I mentioned. Next, saliency maps and grid camps as a visualization method, transfer learning, and fine-tuning. So DCNN, as I mentioned, have achieved expert level performance for various chest pathology. A more efficient DCNN model have been proposed on after another example, VGG, ResNet, DenseNet, and EfficientNet. These DCNNs perform well in image classification tasks, making it possible for computers to perform better than humans in visual classification. On saliency maps and grid camps as a visualization method, a saliency maps calculate the derivative of the source image and thus generate a heat map within the same data resolution, while grid camp uses broader character maps, which typically result in better localization due to higher functionality in greater depth, but are only accessible at minimal resolution due to pooling. Research methodology. As we can see on the left side, there is a flow of illustration, the overview of the research methodology. The process of preliminary study was done to determine the suitable method in image processing of chest X-ray detection. Next, the process of knowledge acquisition, knowledge representation, model design, model development, model testing, and evaluation has been done to achieve the last objective, which is to develop a model with deep CNN architecture. Then we go through research framework with the first objective to determine the suitable method in image processing of chest X-ray detection. First phase is preliminary study. The activities are reviewing the literature of the domain and common technique used and identify problems related to previous study. So the deliverables are the project title, problem statement, research question, research objective, research scope, and research significance. For the second objective, to develop a model with the CNN architecture. First phase, knowledge acquisition. The activities are gather and analyze knowledge source and data. So the deliverables will be literature review and data collection. Next, data analysis. We view and analyze the collected data, and the deliverables will be use attribute. Next, model design. The activities are construct the model architecture and draw the flow diagram. Also, the deliverables will be model architecture and flowchart. Next, model development phase. We develop model using DCNN technique. So deliverables will be system flow diagram. Next, model testing and evaluation. The activity will be model testing and training, also tuning process, and deliverables will be accuracy and time taken. Lastly, documentation. Preparing and writing document as the activities and the final project as deliverables. Next is Gantt chart. So, starting with project title was started in early October. Next, project motivation and project proposal was on October until early December. Knowledge acquisition was started on November until January. Data analysis was on December until early of April. Next is system design and development. Both will start on January. But for system design will be and until early of April, while for system development maybe until early of June. And lastly, system testing and evaluating will be started perhaps on end of March and expected to be done on July. For the last slide is project progress. Currently completed tasks are preliminary study and knowledge acquisition. Future tasks will be knowledge representation, system design, system development, system testing and evaluation. Also, lastly, documentation. So, that will be the end of the slide of the presentation. Thank you.